Welcome back to the office. We want to continue taking a look at section 6.6. And in our next example, we want to actually, I think, skip the one that's listed in our notes and move on to the next one. We'll actually return back to part B in just a moment. So let's take a look at part C quickly. And in this example, we see that there's a radical. We see something out in front of the radical in the denominator. This certainly doesn't look like it'd be something easy to address. In an initial evaluation, we would say, okay, if I'm thinking of other techniques that I have, maybe I would let u be u be x squared minus x, and then I see I have the derivative of that right here. So it's like, maybe that's what we need to do, but you'd find that that doesn't really result in anything. So trying to focus on the methods of this section, we would have to find ourselves sitting somewhere within this theorem here, right? Integrating something that involves a radical. Now, the only one of these that involves something outside of the radical, right? That involves a radical and something outside of the radical is this one. So we're looking to see if it will fit this particular scenario, part C. So let's go ahead and take, part C here. So part C, I'm hoping we'll match to part C. So if I want to do that, what I want to have in the denominator is u squared minus a squared. And I don't have that right now. I have x squared minus x. That doesn't work at all because a needs to be a constant. So what I need to do is I need to think back to my pre-calculus knowledge, and I have to use the method of completing the square. So I need to complete the square. So what I want to do first is complete the square on this. So I have x squared minus x, and that's it. I want to take this expression and write it as a perfect square. In order to do that, I would take this as x squared minus 2 times 1/2 x, and then I need to add something and subtract something to manipulate this in some way. And what I want to make use of is the fact that we'll call it x minus b squared, just for something different. Of course, is x minus b times x minus b, and you would find that this is x squared minus 2bx plus b squared. So writing this as a perfect square, right? Perfect square is this. I want to write this quadratic like this. So x squared minus 2bx, x squared minus 2bx, add b squared, add 1/2 squared. And then I don't want to actually change the value of this expression. So I'll also, after adding it, I will also subtract 1/2 squared. And this gives me x minus 1/2 squared minus 1/2 squared. So I can rewrite this as the integral of 1 over 2x minus 1 times the square root of x minus 1/2 squared minus 1/2 squared. So now I do have exactly that denominator of u squared minus a squared underneath the radical. A couple things that we need to observe here is I want to have u out in front of that, right? Because I'm looking to integrate something that looks like this to get the arcsecant. So I need u out front, but u is x minus 1/2, and this is not x minus 1/2. However, I can pull out a factor of 2 from that to observe this as the integral of 1 over, pull out a 2, and I get x minus 1/2. And I still have, of course, the same thing over here, x minus 1/2 squared minus 1/2 squared dx. And now things look really nice because I see u out in front of the square root, which is u squared minus 1/2 squared. So I want to let's see here, there's a couple different things going on. So let me separate my work to make sure that it's clear here. And now I want to let u be equal to x minus 1/2. And when I do that, that will help make it clear. So I'm going to pull out this factor of 1/2, and then I've got 1 over u times the square root of u squared minus 1/2 squared. Oh, and we of course need what du is. Du in this case is just dx. How wonderful. So we have exactly what we want to implement part C here. So we have du over u times square root of u squared minus a squared. So this will be 1 over a times the arcsecant of u over a. This will be equal to 1 over a. Okay, carry along the 1/2, 1 over a, arcsecant of the absolute value of u over a plus c. 1/2, let's see here, times 1 over 1/2, at 1/2 and 1/2 cancel. So this is just arcsecant. In this case, u itself was x minus 1/2. And when I divide by 1/2, that's the same as multiplying by 2. So this is 2 times the absolute value of x minus 1/2 and plus c. And so we have that. Excellent. If you're okay with this example, feel free to work quickly through the next couple, but I'd like to at least revisit the previous example because that's a really nice short one. In this one, we see something that's really similar to part C that we just did. However, this one is even easier, right? We are going to get wrapped up in trying to apply the methods of section 6.6, which is fantastic because that's what we need to practice. But we don't want to forget about the things that we already know. This, for example, some of us might begin by attempting to complete the square down here so we can observe it as something squared minus something squared, as would be suggested by our theorem. However, we don't want to forget that in this case, if we let u be equal to x squared minus x, then du is 2x minus 1 dx, of course. And this is going to give us exactly the integral of 1 over square root u du, which does not require the methods that we looked at above. And just to complete the problem, this is the integral of u to the negative 1/2. I like to apply the power rule. It's easiest to think of it that way. So I can increase the power by 1, divide by the new power, and add the constant of integration. Division by 2 is multiplication by 2. U itself was x squared minus x, and we are taking the square root of that. So, okay, excellent. Not a big deal. Yeah, so this example and this example are only different by having the 2x minus 1 in the denominator versus in the numerator. So it can greatly change how you approach the problem. And we want to keep in mind, again, those previous techniques that we have. So join me for one more example on this. And again, if you're comfortable, feel free to skip the next example too. That would be absolutely fine. It's up to you, but of course it's there for you. I'll see you back in the office in just a moment.